So it's practice time. We're going to try some problems from the Activity 2 sheet, working with 45, 45, 90-degree triangles. Going to slide this up a little bit. We have two choices. We can use the two sides and the square root of 2 times the side method, which is great if we know one of the sides. We can use the alternate hypotenuse method. If we're given the hypotenuse, then each side is going to be the square root of 2 over 2 times the hypotenuse. If you don't like this method at all, you just like the two sides square root of 2 side, then if they give us the hypotenuse, we will have to divide by the square root of 2 in order to find the length of the side. It can be done. So our first problem here. They've marked off the two congruent sides. Although they didn't say so, this has to be a 45-degree angle. This has to be a 45-degree angle because this one's 90. And the other two angles have to share the other 90 degrees. It looks like they gave us the length of one of the sides. Because it's isosceles, then automatically we know the length of the other side is 7 centimeters. And the length of the hypotenuse is going to have to just be the square root of 2 times the length of the short side. This is going to be the square root of 2 times 9 centimeters. That is the exact length. On problem number 3, they did not give us the length of the shorter sides. They did give us the length of the hypotenuse right here. So we know that equals the hypotenuse. We could use this formula here. That if this is the hypotenuse, that means that equals the square root of 2 times the short side. In other words, the square root of 2 times one of the shorter sides, one of the legs, is going to have to equal 3 meters. So we would have to then divide both sides by the square root of 2 to get the s by itself. So now we have that the length of one of the congruent sides is 3 divided by the square root of 2 meters. Just one little problem. Ancient law that keeps hanging over us says you can't have a radical denominator. We have to get rid of this square root of 2 down here. So we're going to have to rationalize the denominator. We're going to have to multiply the numerator and the denominator by the square root of 2. So now we have that the length of one of the congruent sides is going to be 3 times the square root of 2 over the square root of 4. In other words, the length of one of the congruent short sides is going to be 3 times the square root of 2 over 2 meters, which we could have done using the alternate method here. If you know whatever the hypotenuse is, then the lengths of the two shorter sides are each going to be the square root of 2 over 2 times the hypotenuse. And that's what we got. The hypotenuse was 3, and we ended up with 3 times the square root of 2 over 2. So either way you want to do them, and on the SAT they give you the one formula. Now let's try some from the Activity 5 worksheet with the 30, 60, 90-degree triangles. And when they say the diagrams are not drawn to scale, they are not kidding on this worksheet. I'm a little upset with them, but they have nice big triangles here. So this time, we're not going to be using the formulas for 45, 45, 90. We're going to be using the pictures for the 30, 60, 90. We have, based on the length of the shortest side, the side across from the 30-degree angle, we have the popular representation that the side across from the 30-degree angle is going to be S. The hypotenuse is going to be 2 times S. The side across from the 60-degree angle is going to be the square root of 3 times S. So it's side, 2 side, square root of 3 side. The alternate method says that we base everything on the hypotenuse. And as I said, we will use this later in trig. The shorter side across from the 30-degree angle is going to be half as long as the hypotenuse. The side across from the 60-degree angle is the square root of 3 over 2 times the hypotenuse. Basically, we got these by dividing all of these by 2. So let's look at number 1. On number 1, they gave us 30-degree angle, x is the side opposite, and they told us what the hypotenuse is. So we could use the popular representation that the hypotenuse here is 10, and that's 2 times the length of the shortest side, the side across from the 30-degree angle. So that means this side would have to be, dividing both sides by 2, that means 5 has got to be the length of the shortest side. So this side's got to be 5. According to the picture, that would tell us that the side across from the 60-degree angle is going to be square root of 3 times whatever the shortest side is. So I know it doesn't look like it in the picture, but this is supposed to be the 60-degree angle because they told us this one was the 30. So the side across from the 60-degree angle is going to be the square root of 3 times whatever the shortest side was. And we're done. We have all the side lengths. For number 1, we could have also said that the hypotenuse was 10. So the side that's across from the 30-degree angle is going to be half of 10, which is 5. And the side that is across from the 60-degree angle would be the square root of 3 over 2 times the hypotenuse. And the hypotenuse was 10, which I'm having trouble writing here. When you take the square root of 3 over 2 times 10, you still get the same answer. Let's try number 3. Once again, this is definitely not drawn to scale. They gave us the 60-degree angle and the side that is opposite to it. Apparently, this side here is the hypotenuse because it's across from the 90-degree angle. This side here must be this angle here must be the 30-degree angle. This must be the shorter side. And the hypotenuse, we don't know. The shortest side, we don't know. But we do know that the side across from the 60-degree angle is 12. So we can either go with that is the square root of 3 over 2 times the hypotenuse, or that 12 is the square root of 3, square root of 3 times the short side. I'm going to go with this is the square root of 3 times the short side. So if we want to know what the short side is, we're going to have to divide both sides by the square root of 3. Which would tell us that the short side is 12 over the square root of 3. Which they're not going to leave that way. they're going to want us to rationalize that, multiplying numerator and denominator by the square root of 3. Now we get that the short side is 12 square roots of 3 divided by square root of 3 times square root of 3 is 3. So the short side comes out to be 4 square roots of 3. Wow. The hypotenuse then is going to be twice as long, because if we're going by the basing everything on the short side now, the hypotenuse is twice as long. So the hypotenuse is going to be 8 times the square root of 3 units. We could have done this, as I said, using the alternate formula. We still would have had the radicals. We still would have come up with the same results. So now it's time for you to try some problems. I hope you have printed off the You Try sheet, which has only 4 problems on it. If you can't print it off, then please work them out on your own paper.